In the previous video, we discussed CRE's founding principles. The most important feature of any system is its reliability. Our monitoring doesn't decide our reliability, our users do. And well-engineered software can only get you to 3 nines. But what does 3 nines or 5 nines really mean when it comes to your system being down? It's helpful to think about these targets in terms of their inverse. How much downtime is permissible over a given time span? This unreliability is your error budget. If we're talking about a complete global outage, your system can be in this state for 40 minutes or so over a 4-week period and still meet a 3 nines target. This is just about enough time for monitoring systems to notice something is wrong and for a human to investigate, find, and fix the root cause, if you're lucky. If you're targeting 4 nines, you can only have 4 minutes of complete downtime in that same window. This isn't enough time to loop in a human, so your system has to be able to detect and self-heal complete outages to meet this target sustainably. If you want humans involved in an incident response, you will have to architect your system so that change propagates in waves, and no more than a certain fraction of the system is exposed to a change at once. So this way, the humans still have time to react. 5 nines allows you 24 seconds of complete downtime. It's plausible that this entire time span could actually fit between 2 consecutive data points in your monitoring system. Given this target, restricting the rate of change such that less than 1% of your system or its users can be affected at any given time is the only way to keep humans in the loop. Even then, your margin for error is tiny, and you'll probably need to rebuild your system's monitoring architecture from the ground up. But what does this mean for a system running in the cloud, where you don't have complete control over the underlying infrastructure, and you must rely on your provider's support function to resolve a subset of your reliability problems? If you want to build systems targeting more than 3 nines, you'll begin to find it harder to defend this target with operational response alone, even in infrastructure you control completely. When you factor a round trip or 2 through your cloud provider's support function into the equation, the increase to the time to recovery becomes prohibitive. Google, of course, wants to enable its customers to build reliable systems for their customers on top of our cloud products. If support tickets can't enable this, another approach is necessary, one that enables Google to quickly determine when product changes have impacted its customers, and one that allows customers to reason about the expected availability of those products. In essence, we need some form of integrated operations function between Google and its cloud customers. We can extend this reasoning to our customers' customers, too. We believe that in the long term, some form of operations integration needs to continue down the business-to-business chain until it reaches an end-user-facing product, and that sharing both reliability targets and the data that backs them is an important part of achieving that integration. Otherwise, someone aiming to build high-reliability products on top of a suite of cloud services will have no way of reasoning about the reliability they can expect from a heavily layered stack of which they have no hope of observing or understanding until it fails. And so CRE was born, to pioneer and develop what these integrated operations might look like.